All right, so to show all the solutions of a system of linear inequalities, what you do is you graph the solutions of each inequality. So you're going to have two inequalities, right? You graph the first one like we talked about in the previous section, 5, 5, and then you graph the other one, okay? The solutions of the system are represented by the overlapping shaded regions. Below are the graphs of example 1A and 1B. Okay, so here, let's look at 1A. So what I'm going to do is I'm going to show you this here. And I think I'm going to use, I'm trying to figure out which colors to use. I'm going to use this one. Okay, so for this, you see how there's two lines? This represents two different inequalities. So this first inequality here is, it's a solid line, right? And all of this are these are the solutions, okay, of this particular line, all right? Now, there's another inequality here, and the solutions to this inequality are everything below the line, which is here, right? But notice that in this section here, this is where both of the shaded regions overlap. And that overlapping, that's what this problem is talking about. These are where the solutions lie, are in the overlapping, where both of these linear inequalities overlap. So if you see this point right here, which is 2, 1, so this is the point 2, 1. This is a solution. All right. So, and really anything, any point in the shaded region is a solution. All right. Anything, remember, anything along this particular line would also be a solution, but nothing along that dashed line would be a solution. So there's actually a ton of ordered pairs that would be solutions. Okay. And what's really, really interesting, like when you do something like in the previous example that we are looking at, and you find, like on our first example here, that this ordered pair is true for this one and it's true for that one, well, that means that the point is in both of these shaded regions. However, in this other example, did you notice how it was true for one but false for the other? Well, what that means, it would be like a point, I'm going to use a different color, like right here, okay, like this point. Well, this point is a solution of this yellow, right? So that would give you a true statement, but it's not a solution for this pink region. So that's why when you're doing this, you'll have one that is true and one that is false, because it actually is true for this yellow, right? This inequality, that is a solution, but it's not a solution for this pink, okay? So for it to be a true statement for both, it has to be a solution that is in the shaded region of both. Now, what do you think if I had a point over here? How do you think that would play out? Well, if there's a point that's not in either of them, then what it would be is it would be a false. It would be a false statement here, and it would also be a false statement here. So visually, that's what it means, okay, when you're trying to figure out solutions. If it's in here and it's not neither, it's not a solution of this one and it's not a solution of that one, okay? Here, it's a solution of one, but it's not a solution of the other. So for it to be a solution of the system, it has to be a solution of both, and so it has to be in that the part where the shading overlaps, okay? So that's really important, and that's really what this is showing here. So for this next example, so we have this, this dash line, and basically the region for the dash line is everything below. So this is all the dash line, right? So this dash line. And then this other inequality here, the section for that one is everything above of it here. Okay, so it's everything here. So obviously the region that they both overlap is this region right here. So the only solutions to this system are any ordered pairs that are in between in here. These are the solutions, right? So this one is not in this overlapping, this 2, 0, it's not in the overlapping shaded region, so it's not a solution. It is a solution to one of these